Here we go. We are finding the range of the interval from 0 to pi, which, understand what that means. If we're finding the range, we are finding the lowest y value and the biggest y value. That's what range means. So in other words, we are finding the absolute max and absolute minimum of this problem. Everybody understand what I'm saying there? Cool. There's my function. What do I need to do with that function to find the absolute maximum and minimum? Take the derivative, and so we are going to find f prime of x. I'm taking the derivative of sine x times cosine x. Which derivative rule do we possibly need here to take the derivative of sine x cosine x? Product rule. So we're doing first times the derivative of the second. What's the derivative of cosine going to be? Negative sine. Plus second times the derivative of the first. What's the derivative of sine x going to be? Cosine x. That's important. Don't forget about product rule. We haven't done product rule a bunch lately. That doesn't mean it's not a thing. I don't know. If you want to be good on this next test, I'd make sure you look and see, do I need product rule or not? Because there's a good chance you would just skip it. Don't. If I were to rewrite this to make life a little bit easier, I could write this as minus sine of x squared, because there's two of them, plus cosine squared x. Sine squared, cosine squared, the only difference is that sine is negative. Everybody good to that point? I am taking the derivative. Once I find the derivative, if I want to find max and mins, now I'm going to set it equal to 0. I'm going to move the sine squared x over so that we can set them equal to each other. Cosine squared x equals sine squared x. And then think about that for a second. I want to know on the unit circle between 0 and pi, because that's what we were doing here. Where in between 0 and pi is cosine squared going to be exactly the same as sine squared? Okay, or in other words, my x value squared needs to be equal to my y value squared. What has to be true about your x and your y value so that when you square them, they're equal to each other? They're the same. Okay, so think about that. We could do some more like deep solving here, but I think it's easier just to think of it in terms of that. Where is cosine squared x going to be equal to sine squared x between 0 and pi? Pi over 4 on your unit circle. Okay, right here at pi over 4, because that answer is radical 2 over 2, comma radical 2 over 2. So x equals pi over 4 is an answer to this question, right? And 3 pi over 4. Why 3 pi over 4? Yeah, so at 3 pi over 4, one of them is negative, but it doesn't matter because I'm squaring it, right? If I took the square root of both sides, I would say plus or minus on each of them, so it doesn't truly matter anyways. So that is why I want pi over 4 and 3 pi over 4, because right here they would be the same, except the x would be negative, but who cares because I'm squaring it. Makes sense on where I found those numbers. Those are critical numbers. We could go ahead and make a sign chart if we wanted to, but a sign chart doesn't even really matter here. You can just plug them in and check, okay? Because I'm finding absolute maxes and minimums, we will find out if they're a max or a minimum really quickly, if it's the biggest number, if it's the smallest number. That's going to be a better check of it more than anything else. At this point, let's say I said justify where the absolute maximums and minimums were. Remember, this is the one time where justify does not mean words. How do you justify if something is a max or a min? An absolute max or min? My t-chart. Okay, my t-chart over here, I'm going to have x and f of x. X and f of x. What x values do I need to test to see if they are maximums or minimums? 0. Pi over 4. 3 pi over 4. And pi. End points and critical points. The end points of 0 and pi, the critical points of pi over 4 and 3 pi over 4. Bless you. What equation am I plugging those back into? The original, the sine x cosine x equation. Okay, so think about that. I'm doing sine x cosine x. So sine of 0. Here's sine, or here's 0 right here. What's sine going to be at 0? 0. Sine of 0 is 0. So who cares what cosine at 0 is? Because it's going to cancel out anyways. It's going to get me 0. pi over 4. Sine of pi over 4. So again, we're right here on the unit circle. Sine at pi over 4 is going to be radical 2 over 2 times cosine of pi over 4, which would be radical 2 over 2. Square root of 2 times square root of 2 is 2 over 2 times 2, which would be, so my answer, 1/2. I'm doing 3 pi over 4. So sine at 3 pi over 4. Again, know where 3 pi over 4 is. There's 3 pi over 4. Sine is going to be just radical 2 over 2. What's cosine at 3 pi over 4 going to be? Negative radical 2 over 2. I multiply, I get negative 2 all over 4. I get negative 1/2. Everybody good there? And then I do pi. So over here at pi. So pi's on the right side. If I'm doing sine at pi, what's sine at pi going to be? 0. And so times cosine of whatever is going to be 0. So if I'm looking for the range, I've not seen range a ton on the AP exam, but they do it every once in a while. Range just means the minimum and the maximum. What's my range going to be on this problem? Negative 1/2 to positive 1/2. Everything about this problem is going to live in between those two numbers based on the range, based on finding our maximums and minimums. Let's look at that on Desmos real quick just so you can see it. So sine of x, cosine of x. Let's go between x equals 0 and x equals pi. Oh, I typed in something weird up here. Hang on. Yeah, it's because this is thrown. There we go. X equals 0. X. Oh, look, there's the highest point. It's at pi over 4. What's that value? 0.5. Hey, look, here's the lowest point in between those intervals. It's negative 0.5. Where is that happening at 3 pi over 4? It's just showing you exactly what we found on the other part. Questions on that?